Good morning. This is Dr. E. Manjoolatha, Assistant Professor of Mathematics, Annamacharya Institute of Technology and Sciences, Tirupati. Today, we are going to discuss about the Gauss divergence theorem in vector integration. In the previous sections, we discussed about the line integral, surface and volume integrals in vector integration. Now, come to this theorem. Gauss divergence theorem states transformation between surface integral and volume integral. Let S be a closed surface enclosing a volume V if f bar is a continuously differentiable vector point function, then volume div f bar is equal to surface of f bar dot n bar. This is integral V div f bar dv is equal to integral S f bar dot n bar ds. This is the transformation. This is the relation between volume and surface. This is known as the Gauss divergence theorem. See the first question. If f bar is equal to az I bar plus by j bar plus cz k bar, where a, b, c being constant, show that surface integral f bar n bar ds is equal to 4 by 3 pi of a plus b plus c, where S is the surface of a unit sphere. This is important. Unit sphere. Given sphere is a unit sphere. Now come to the solution. So this is the sphere equation. Surface of a unit sphere. And given vector is this one. Now applying the del on that vector, we get del dot f bar. So why you are using the dot product here? See the formula. See the formula. This is div f bar, means del dot f bar. So that we are applying the del on the given vector f bar. So when applying this dot product, you can get dou by dou x of ax. I bar dot I bar equal to 1. I bar dot z bar equal to 0. So that you get first term as this and second term as dou by of by and dou by dou z of cz. So again do the partial differentiation of ax with respect to x. You get a, and partial differentiation by with respect to y you get b, and partial differentiation of cz with respect to z you get c. So totally you got del dot f bar is equal to a plus b plus c. So by using the Gauss divergence theorem, you know that volume, integral of volume is equal to the surface. So we can write this surface integral f bar n bar ds is equal to integral volume del dot f bar dv. Substituting del dot f bar value, we get like this, a plus b plus c dv. So a plus b plus c is a constant and integral of dv you get v. Here you can find the v value also, because given vector is a given sphere is a unit sphere. You know that volume of the sphere is formula 4 by 3 pi r cube. Here r is equal to 1 because unit sphere. So you can get v is equal to 4 by 3 pi into 1, that is 4 pi by 3. So substituting this v in this, we get surface integral f bar n bar ds is equal to a plus b plus c into 4 pi by 3. This is a simple question. And come to the next one. Next question. Apply Gauss divergence theorem to evaluate double integral x cube minus yz dy dz minus 2x square y dz dx plus z dx dy over the surface of the cube bounded by the coordinate planes and the planes x equal to y equal to z equal to a. So what they are given in the question is, see, this is, here you have to pick the f bar. They are given in the question f bar and the planes. Now come to our Gauss divergence theorem. We know that the relation, the transformation of the surface and volume. Integral surface integral f bar n bar ds is equal to volume integral del dot f bar dv. So you have to pick the f bar from here. See, this is first scalar x cube minus yz. This is second scalar and this is third scalar. See, write the scalars combination when then we get the vector. So f bar is equal to x cube minus yz I bar minus 2x square y j bar plus z k bar. And applying the del on this vector, so this we can get. And do the dot product on this. The first term will be dou by dou x of x cube minus yz. The second term will be dou by dou y of minus 2x square y. And third term will be dou by dou z of z. So doing the partial differentiation on these. So with respect to x means first term x cube, that is 3x square, and the second term here yz is a constant, so that we will get the 0 and come. So totally dou by dou x of this, you get 3x square only, and come to the second term dou by dou y of minus 2x square y. Minus 2x square is a constant, and do the differentiation of y, you can get 1. So totally you get minus 2x square. And dou by dou z of z, this is 1 you can get. So what's the value of del dot f bar is 3x square minus 2x square plus 1. So doing the simplification, see, come to the Gauss divergence theorem. So substituting the del dot f bar, you can get like this: 3x square minus 2x square plus 1 dx dy dz. And come to the limits. They are given clearly in the question. Coordinate planes and the planes x is equal to y is equal to z is equal to a. So that the limits will be 0 to a for all the variables. So x has a lower limit 0 and upper limit a, and similarly y also has the lower limit 0 to a, and z also the lower limit is 0 and upper limit is a. And doing the simplification here, you get x square plus 1. So first do the integration with respect to x, or with respect to y, or with respect to z, because you are having all the variable limits as a constant limits. So first you are doing the integration with respect to x. So term by time you do the integration. The first term is x square. x square dx, x square dx. X square dx means x cube by 3 you can get. And here 1 into dx, x. So substituting the upper and the lower limits, you get a cube by 3 plus a. And come to the next integration with respect to y. And come to the next integration with respect to y. So a cube by 3 plus a is a constant. Keep outside and do the integral dy. Integral dy, you get y. So substituting the upper and lower limits, you can get a. So a cube by 3 plus a of a is totally constant term. So keep outside the term and do the integration finally with respect to z. That is integral of dz, you get simply z. And substituting the lower and the upper limits, you get a. So, and simplifying these terms, you get surface integral f bar n bar ds is equal to a5 by 3 plus a cube. This is the surface integral value. This is second problem. And come to the third one. Evaluate double integral x cube dy dz plus x square y dz dx plus x square z dx dy, where S is the closed surface bounded by the plane z equal to 0, z equal to b, and the cylinder x square plus y square equal to a square. See, they are given f bar in the question. So when you pick the scalars, the first scalar is x cube, and the second scalar is x square y, and the third scalar is x square z. When you are writing these scalars combination, you can get the vector f bar. So that f bar as x cube I bar plus x square y z bar plus x square z k bar. So you know that we are going to apply the del on the vector f bar. So del dot f bar, this is the vector differential operator del, and this is the given vector f bar. Doing the dot product on these, using these results, you can get dou by dou x of x cube as a first term, dou by dou y of x square y as the second term, and dou by dou z of x square z is the third term. So doing the partial differentiation, what we get? X cube 3x square. And with respect to y means x square is a constant, and with respect to y means 1. 1 into x square, you got x square. And come to here also, x square is a constant because you are doing with respect to z. So doing with respect to z of z is 1. 1 into x square, you get x square. So adding all these x squares, you get del dot f bar is equal to 5x square. Now, by Gauss divergence theorem, you know that the surface integral is equal to the volume integral. So, substituting this del dot f bar in the volume integral, 5x square dx dy dz. Then come to the limits. What about limits? They are clearly given the z limits in the question. That is, z is equal to 0 to b. And using this given equation, you have to find the y limits and as well as x limits also. So from the given equation, y square is equal to a square minus x square, y is equal to plus or minus square root of a square minus x square. So y limits as minus square root of a square minus x square to square root of a square minus x square. And from the given equation, you have to write the equation as like this also. In this, put y is equal to 0, you get x limits. So x limits is minus a to a. So here, first do the integration with respect to z. So x square keep outside, it is not a constant, just keep outside. And integral dz. Integral dz means z. So upper and the lower limits will be 0 to b. And one more thing you have to observe here, you are writing minus a to a limits as 2 times of 0 to a, and the y limits are minus 2 plus here. This also you are writing 2 times of y is equal to 0 to. Why you are writing like this means the given function is x square. X square is an even function. So when the given function is even function, you have to write the limits as like this. Okay. So limits will be cleared, and uh, after the integration with respect to z, do the simplification. Come to the simplification. So upper and lower limit values, when you're substituting, you get only b. Now do the integration with respect to y. So x square b keep outside, and integral of dy is y. So here the limits is 0 to square root of a square minus x square. And substituting the lower and the upper limits, you get this value. So b constant. So keep outside. Already you are having here 20. 20 into b is a totally constant term. And this is the final term you got. X square into square root of a square minus x square integral dx. So this is difficult to do the integration, so that you have to convert this into a polar coordinates. For this, substituting x is equal to a sine theta. When you are substituting x is equal to a sine theta, automatically what about dx? So do the differentiation of x, dx is equal to a into, so for the differentiation of sine, you get cos theta, and theta will be d theta. Okay. So when you're differentiating with respect to theta, you get dx as like this. And you will change the x limits into a theta limits. So what is the lower limit of x? 0. So substituting in this x is equal to a sine theta, you get 0 is equal to a sine theta. This means sine theta is equal to 0. When sine theta equal to 0, if you keep 0, then sine theta will be 0. Okay. Come to the upper limit of x. What is the upper limit of x? A. So this is the upper limit. Substituting this upper limit in this, x is equal to a sine theta, you get a is equal to a sine theta. On the simplification, you get sine theta is equal to 1. So if theta is equal to pi by 2, it will becomes to 1. So the theta limits will be 0 to pi by 2. This is theta limits. So you are changing the variable x completely in terms of theta. So including the limits also. This is theta limits, and this is x square. So you know that x is equal to a sine theta. X square means a square sine square theta. And this calculation is here. Square root of a square minus x square means square root of a square minus x square means a square sine square theta. So a square is a common term, and it will come outside the square root. A into 1 minus sine square theta. 1 minus sine square theta will becomes to a cos square theta, and totally you got a cos theta. This is square root of a square minus x square value. Square root of a square minus x square value is this. And what about dx? Dx is equal to a into cos theta d theta. So completely you have to change it the x into a theta. Now doing the simplification, a square a that is a power 4, that is a constant, and the remaining is sin square theta cos theta into cos theta cos square theta. You know the formula of this, 0 to pi by 2 sin power m theta cos power n theta d theta. If m is equal to n, then only apply the formula m minus 1 by m plus n. M is 2. M is 2 minus 1 by m plus n. 4 into 1 by 2 into pi by 2. This is the formula. When applying this formula, you get pi by 16. So totally the result will becomes to 5 by 4 pi a power 4 b. So this is the triple integral value automatically. This is equal to is double integral f bar n bar ds. So that finally you got the surface integral as 5 by 4 pi a power 4 into b. So these are the problems on Gauss divergence theorem. Okay, thank you.